Good morning, everybody, and welcome to another fabulous math class. It's Mr. Taco here, and yes, it is pajama day. If you haven't noticed by my robe and my headband keeping all my hair together, I look like some sort of ninja chef. It's kind of a good look for me. I'm really feeling it, and I might just start dressing like this every day. And who's going to stop me? You? No, you're not. Okay? So today, we're adding mixed numbers with unlike denominators. I bet you're thinking, wait, Mr. Taco, we did that yesterday. Correct, we did. We're going to do it in a little bit of a different way today, though. We are going to really think about and look at how we can use improper fractions to add mixed numbers. It's going to be a little bit of a different strategy than yesterday. Our goal, as a reminder, our goal with math is to find the one strategy, at least one strategy, that we can do accurately and we can do efficiently. We can do it in as few steps as necessary while still getting an accurate answer all or almost all the time. Okay? For some of you, this strategy might be more challenging than yesterday's strategy, our separate then add strategy. And that's okay. Give it a try today. If you decide after today, after you try the strategy and do the exit ticket, that you like the other strategy better, do the other strategy. Okay? The end goal with math is to be flexible and be able to use multiple strategies, but then also have your go-tos. Right? We talked a lot last year about having a go-to strategy for multiplication, whether it's area model, standard algorithm, and having a go-to strategy for division, whether again it's standard algorithm or it's some version of modified area model or it's repeated subtraction. And adding mixed numbers is no different. There are multiple ways to get to the same answer. And we're going to go over another one of those today. You're going to need the usuals, something to write on, something to write with, our handy dandy multiplication table, which I was kind of thinking we need to stop calling it a multiplication table because it does so much more than just tell us our multiplication facts. Today we're going to see it tells us, and in our multiplication table, only with the information in our multiplication table, it tells us all kinds of fraction information too. So it's not just a table that tells you what times what equals what. It does a lot more than that, okay? And then here are our ICANNs today. I can create equivalent fractions, and I can add mixed numbers with unlike denominators. So let's get into this improper fractions method. Oh, and it's going to bother me if this is not in the center of the screen. There we go. Okay. I'm okay. Now, when we're talking about making improper fractions, and as a reminder, an improper fraction is a fraction where the numerator has a greater value than the denominator. The number in the numerator spot is a greater value than the denominator, like 3/2, for instance. That tells us that that fraction has a greater value, is greater than 1. If there's more numerators than our pieces that fit into 1, 3/2, 5/4, 10/5, 100/7, okay? That fraction is greater than 1, and we can make it into and convert it into a mixed number. We can also do the inverse. We can take mixed numbers and convert them into improper fractions, and we're going to do that today. I'm going to scoot a little bit closer to our multiplication table here because there's some great information found here. For this lesson, what we want to know is, what are all the fraction equivalents of our whole numbers? And for instance, how many, we know that any fraction that's an equivalent of 1, the numerator and the denominator are going to be the same, top and bottom. So 2/2, 3/3, 4/4, etc., until the cows come home. But did you know our multiplication table also tells us fraction equivalents of other whole numbers? And here's how to look to find them. Remember back when we talked about how fractions were really just division in disguise? This multiplication table also shows division facts because division is the inverse of multiplication. They do the sort of opposite operation. So what we can look at, let's take fifths, for instance. We know that 5/5 equals 1. I'm actually going to erase and replace here. 5/5 equals 1. So then, how many fifths would be equivalent to 2? Or in this case, what divided by 5 is 2? And you can find that in here. Here's our 2. Here's our fifths. And right here, 10/5 equals 2. Just like how you can do 5 times 2 is 10, right? 5 times 2 equals 10. Because they're inverse operations, 10 divided by 5 equals 2. Would you agree? And remember, fractions are division in disguise. So 10 divided by 5 equals 2, or 10/5 equals 2. And you can find them here. 10/5 equals 2. And you can do that for any one of our numbers on here. Let's take 40. Here's 40, right? 40, let's see what row it's in. 40/8 equals 5. Check that out, because we know 5 times 8 is 40, or 40 divided by 8 is 5. Okay, just like 10/5 equals 2. Okay, and this is true straight down those rows. 10/5 equals 2. 15/5 is equivalent to 3. 20/5 is equivalent to 4. So if we were to write our counting numbers, but in fraction form, it would look like this. Are you noticing a pattern? Right? 5, 10, 15, 20. In a fractions bar, right, if we divide this 1 into fifths, we color in all 5, we have 1. If we were to have 10 of these pieces, 10 of these fifths, 6, 7, here's our first 5, 6, 7, 8, 9, 10. So we have 10 pieces. Each piece is worth 1/5 of a whole. So here's our 10/5. And how many whole fractions bars are filled out? 2. So we can use this knowledge to solve mixed number addition problems by converting our mixed numbers into improper fractions. Here's how it works. Let's take a problem like 3 2/3 plus 5 3/4. Okay? First thing we're going to do, step 1. Can I write it up here? Nope. I'll write it next to it. Step 1, find a common denominator, just like we've been doing for all the other problems here. Okay? So looking at our thirds and our fourths, if we were to go to the thirds row and the fourths row, what's a number that shows up in both? 12. Okay? So now we're going to convert these fractions, 2/3 and 3/4, into 12ths. So 2/3 equals, we're going to multiply it by an equivalent of 1. And I do want to say it is very helpful to write it out. You can't see because of glare. There it is. It is very helpful to write it out like this. 2/3 times some equivalent of 1 equals some twelfths. If you know that 12 is going to be your common denominator, write it out in this format. Okay, the 5th grade mathematicians I'm seeing with kind of the most errors in this step, it's because the organization isn't there. So try it this way and see if that helps you stay organized. 3 times what is 12? Well, you could look on our chart, or you could, if you know the fact, 3 times 4 is 12. Because this is an equivalent of 1, we're going to fill in 4 fourths. Now, multiply the numerators. 2 times 4 is 8. So we know that this 2/3 is equivalent to 8 twelfths. So what are we going to do? We're going to erase and replace. Yeah? Now, 3/4 equals how many twelfths? So let's set up our format the exact same way here. 3/4 times some equivalent of 1 equals some number of twelfths. 4 times what equals 12? 3. So we're going to use 3/3 as our equivalent of 1. When you multiply by 1, you're not changing the value. Now, multiply the numerators. 3 times 3 is 9. So now we know this 3/4 is equivalent to 9 twelfths, so we can erase and replace. So now we've rewritten our equation, haven't changed anything, but we've rewritten our equation as 3 and 8 twelfths plus 5 and 9 twelfths. Now, step 2. Turn whole numbers into improper fractions. And we're going to make them improper fractions with your common denominator. Okay, so what's our common denominator here? Twelfths. So we want to know how many twelfths equals 3, how many twelfths equals 5. There's 2 ways you can do it. Go to your multiplication chart here. How many twelfths equals 3? So let's go to our 12 down here and see 1, 2, 3. And there's our 3 all the way up there. We have 36 twelfths. 12 twelfths equals 1. 24 twelfths equals 2. 36 twelfths equals 3. So I'm going to rewrite my equation all the way over here. I'm going to rewrite this 3, erase it and replace it, as 36 twelfths. And I'm going to put a plus sign in the middle, because 3 and 8 twelfths is the same thing as 3 plus 8 twelfths. Now, what are 5? Or what is 5 in twelfths? So go back to your chart. 1, 2, 3, 4, 5. 60 twelfths is equivalent to 5. So we're going to rewrite our 5 as 60 twelfths. Some of you may have picked up on this, that, oh, well, 12 times 3 is 36. So if I have that memorized, I can just do, if I wanted to make 3 into some form of twelfths, all I have to do is go 3 times 12. If I wanted to make 3 into some kind of sixths, all I do is 3 times 6. If I wanted to make 3 into hundredths, 3 times 100. and there's my fraction. Okay, there's your shortcut if you want to try doing it using multiplication facts instead of your multiplication table. So now, what we're left with, if I scoot all the way over here and tilt it up, 36 twelfths plus 8 twelfths plus 60 twelfths plus 9 twelfths equals, and again, remember our denominator stays the same when you add. You do not add 12 plus 12 plus 12 plus 12. That's going to change the size of your piece, and it's not going to give you an accurate answer. So 36 plus 8, 60 plus 9. I'll do it like this. Because of the commutative property, you could add these up in any order. So we have 36 plus 8 is 44. 60 plus 9 is 69. 69 plus 44 equals 113 twelfths. Now, could I just leave it like that? I could, but it's an improper fraction. So the last step is, well, the third step is to add, isn't it? And then the fourth step is to convert your answer into a mixed number. And again, we can do this using our multiplication table. If I have 113 twelfths, how many whole numbers, how many ones can I make with 113 twelfths? If I do 113 divided by 12. Let's go over to our chart and let's see. Let's take a look at our multiples of 12. How close can I get to 113 without going over? 12, 24, 36, 48, 6. I feel like I need that, the music from the, if you ever watch Price is Right when they have like the mountain climber game and the little mountain climber climbs up, climbs up, climbs up, it gets close without falling over, hopefully. This is what I need here. As close as we can get to 113 without going over. Keep going, keep going, keep going, keep going. Ah! I'm at 120, that's too many. I'm going to go back one. So 108 twelfths equals, if we follow this all the way up, 108 twelfths equals 9. So I know my answer, I know we're moving around a lot today. My answer, so 113 twelfths, is going to be 9 and something. So I need to know how many twelfths equals my 9 so I can figure out my remainder. So 9 times 12, again, was 108. So I'm going to take that 108 twelfths and subtract it from the 113. And it equals 5. So I know I have 5 twelfths left. Essentially here what I did was 113 twelfths minus 108 twelfths. Because this 108 twelfths we converted to our 9 wholes. Okay? Now, like I said at the jump, if this strategy feels really challenging for you, I encourage you try it today and be aware that it's really challenging for you. Okay? There's nothing wrong with math being challenging. In fact, that's the good stuff when math is challenging. Okay? If you find this to be challenging, this particular strategy, and you found yesterday's strategy, our separate and then add strategy, to be a lot easier, well then today's the only day you really have to try this particular strategy. And if the other one works really well for you, great. If you are someone, and I know there are many of you fifth grade mathematicians out there that really understand that division in disguise and that making improper fractions into mixed numbers thing pretty well. So this strategy might work better for you than yesterday's strategy, and that's great too. Okay? Our goal here with this is to try every strategy and think about every strategy, and then zero in on your go-to that's going to work for you. Okay? Let's go to the digital whiteboard and let's try one more before we get out of here. So let's try this one. Let's try one. Oop, I got the rainbow pen on. I don't want the rainbow pen. The rainbow pen's great, but it's a little distracting. 1 3/8 plus 3 1/2. 1 3/8 plus 3 1/2. So first step, find your common denominator. Find that common denominator. And yeah, our common denominator is going to be in eighths, right? Because this 2 will expand out, and 8 is a multiple of 2, so we can use that. So 1/2 times some equivalent of 1, and how would that be in eighths? 2 times what equals 8? 2 times 4 equals 8, so use your 4/4. And then 1 times 4 equals 4. So we know this half is equivalent to 4/8, so we can erase it and replace it. Okay, so now we have 1 3/8 plus 3 4/8. So now, let's go ahead and make our improper fractions. So how many eighths equals 1? Oh, we know that. That's an equivalent of 1. Oh my gosh. Same numerator and denominator. Erase and replace to make 8/8. How many eighths is our 3? Right, we know we're going to 3 equals how many eighths? And remember, you can use multiplication for this. 3 times 8 is 24. And if you were to draw that out, you were to draw out 3 fractions bars, each cut into eighths, and then color in 24 pieces, you'd have a perfect fit. So our 3 is equivalent to 24/8. Now, add them up. 8 plus 3 is 11. 11 plus, so here's 11. 11 plus 24, whoops. Zoop, zoop. 11 plus 24, 35. And 35 plus 4, 36, 37, 38, 39. So our final answer here would be 39. And then what goes in the denominator? Yep, still eighths. When we're adding, our denominator does not change. There's still a few of you out there that are trying to add your denominators, and that changes the value of your fraction. All right, 39, what's 8 times 4? 30 seconds. That's a much different value than 39/8. So now, last thing, convert this into a mixed number. So what's 39 divided by 8? How many 8s can you make with 39 without going over? Let's count by 8s and figure it out. 8 plus 8 is 16. And I'm counting on, following on my fingers. So 8 times 2 is 16. 8 times 3, 24. 8 times 4, 32. 8 times 5 is 40. That's too many. I'm going to put that thumb back down there. And we have 4. And then how many eighths left over? So we took our 39 eighths. We took 4 wholes out of it, or 8 eighths, 16, 24, 32 eighths. So what's 39 eighths minus 32 eighths? (39 eighths) minus 32 eighths. And that equals 7 eighths. So our final answer here is 4 and 7 eighths. Okay, you're right, it is a lot of steps. It's a lot of steps. Okay, and it can be challenging to keep track of all the steps, which is why it helps to have lots of scratch paper, math notebook, loose paper, a big whiteboard like I've got. Okay, so lots of room to write your work, lots of room to stay organized. Okay, but by following those steps behind me, find a common denominator, turn your whole numbers into improper fractions, add them up, then convert your answer into a mixed number. Give it a try today. I am willing to bet that some people are going to like this strategy. Some people are not going to like this strategy, and that's okay. Give it a try today. If it's not for you, good thing we learned another strategy yesterday. That can be your go-to. Okay, everybody, thank you so much for tuning in. I appreciate you. I miss seeing you in the classroom, but we're doing our best from here. And if you have any questions, the Zoom room will be open in just about 5 minutes. All right, good luck.